folks. Good evening, good morning, good day, whatever time that you are actually watching this particular video. This is your tutor, Mr. Matleviani MS again. Today we will be dealing with another part of mathematics, which is very, very important, which is called mensuration. And please, don't read me wrong. We will be dealing with volumes, like areas, perimeters, total surface areas, so on and so on. Okay. And if you are new to my channel, please don't forget to subscribe, like, and share this video with other folks. Okay, now, without wasting any time, let me just hop into it. Okay, now, when somebody talks about a volume, what are we actually talking about? A volume, people, is actually the amount of space contained within an object. The amount of space contained within the object. I'm still going to explain that, okay? Or if you don't want to say that, you can actually say it is the amount of space within a solid shape, because an object is actually a solid shape. All right, right, we'll see this as we continue. Now, let's check. You are actually having, we can't talk about volumes unless we start. This is our point of departure. We must first have two-dimensional shapes. When we say these are two-dimensional shapes, we mean they are flat shapes. It means you can actually take them and put them on a flat surface. Okay, so this one, you have your circle there, you can put it on a flat surface. You have a triangle, you can put it on a flat surface. You have a quadrilateral here, which might be a rectangle, then you put it on a flat surface. Okay, then these are two-dimensional shapes. We can't talk about volumes unless we are going to talk about the two-dimensional, because volumes are actually translations. They are actually translations of these two-dimensional shapes. Okay, now, suppose you take a circle, you take this flat shape, and then you move it vertically downward. Okay, you either move any flat shape, you move it vertically downward at an angle of 90 degrees, at a right angle. Okay, then we will actually be creating a volume. Okay, now let's check. If we move them down, you see, now you are actually moving it down. It actually gives you what? It gives you an object. You are no longer having the flat shape. It is now an object. Then these objects are now, these objects are now prisms. You see, because you move it down at an angle of 90, or if you don't want to move it down at an angle of 90 degrees, suppose we have a circle, and then we try to move it to the right or to the left, but we still move it at an angle of 90 degrees. It will still create a solid shape or a solid object. Okay, now this is a solid, this is a solid, this is a solid. All of them, they are no longer flat shapes, but they were generated by doing what? By translating the flat shapes either up or down at an angle of 90 degrees, or to the left or to the right at an angle of 90 degrees. Okay, now immediately when you translate them, then the third dimension is created, and that particular third dimension is what? Is the height, and then we start to call them three-dimensional shapes. Okay, we call them three-dimensional shapes or three-dimensional objects, and then now they are solid shapes now. Okay, and then we call them right prisms. Why do we call them right prisms? Because they are created by moving flat shapes. They are created by moving two-dimensional shapes at an angle of 90 degrees, either down or up, or to the left or to the right. Okay, so it means translation of flat shapes vertically down, up, to the left or to the right at an angle of 90 degrees will create what? Will create solid shapes, and those shapes will be known as prisms. Okay, now the space that is created in between, you see, the amount of space contained within this solid object, okay, the amount of space contained within this particular prisms, that is what you will call the volume, and that is our bone of contention. We will be specifically looking at this space, which you call the volume. All right, so let's move on. We will look at right prisms. I said we call them right prisms because we are actually translating them at right angles. We are translating them up, down, left, or right at an angle of 90 degrees. Okay, so I want us to start from practical to theory. For an example, let's say we have a can. We have a can here, a Coca-Cola can. Okay, and then we also have a present box. We also have a shoe black box. and then we also have a camping tent. Okay, if we draw around the edges of this particular shape, this is what you will actually have. And then we also draw around the edges of the present box, and the edges of our shoe box, and the edges of our camping tent. And then if I remove my Coca-Cola can, then this is the shape that will remain there. Okay, this is the prism. It's now a prism. This is a solid object. And then I remove this one. You also have another solid. And then I remove the black shoe box, and then you also have another solid. I remove the tent. Then all of these four, they are actually basic right prisms that we'll be dealing with when in the section of mensuration, or in the section of measurement. Okay, so to say, if you're comfortable with the word measurement, then we're dealing with that. Okay, now you can check. This is the first one. So we're going to be looking at the dynamics. We're going to scrutinize each and every prism, because they are now right prisms. Remember, they are actually generated by moving this flat shape down. So it means we have actually taken this flat shape, which is a circle, and then we move it down to create this space, which is a volume. Okay, the same thing apply here. We have taken this shape, which is a square, and then we move it down, or we have actually taken it from the bottom, move it up at an angle of 90 degrees. Then we have this prism, or we have this solid shape, or we have this three-dimensional shape, or this three-dimensional object. And the same thing apply here. We actually have what? A rectangle, which was translated down at an angle of 90 degrees or up, and then we get this prism. Okay, and then we also have what? We also have a triangle that was translated. But now look at this one. I'm still going to explain this one. This one, when we say something is a prism, is when it is actually put in the correct orientation. So this one is not put in the correct orientation. When it is in a correct orientation, it means these parts which are congruent, which are the same in every respect, the top and the bottom are supposed to be the same. So it means we must put it in such a way that the bottom part is the one that is on the flat surface, and the bottom part is the same as the top part. Okay, and for every hidden side of our objects, of our three-dimensional shapes, we will actually use broken lines. Okay, these broken lines indicate that these are the sides that you cannot see. Okay, they are hidden. Now let's check the first one. The first one, we'll call it a cylinder. Okay, because it has the radius. You can't talk about a circle unless you have the radius, because the radius is the one that determines the area of a circle. The bigger the radius, the bigger the area. Okay, but immediately when we take this particular circle and translate it, move it down at an angle of 90 degrees, then we have the third dimension, which is our height. Okay, and then we cannot talk about a flat surface. We can't talk about this particular flat surface unless we talk about the circumference. So there will always be a circumference, which will be the edge of a circle. Okay, and that particular circumference is generated by actually revolving. Okay, revolving the radius at a fixed point, which is the center, around. Then it creates the circumference. Okay, and the second one is called a cube, because all the sides are actually equal. This is a side, this is a side, this is a side. So all of them are equal. Then it is a cube. Then the third one is a rectangular prism. A rectangular prism has these three dimensions. It has the length, it has the breadth, it also has the height. Then you know this is a rectangular prism. And then we also have the fourth one, which is a triangular prism. It is a triangular prism because it has the height. But be careful here, we are actually having two heights. If you rotate it and you make sure that this part is at the top or is at the bottom, then this part will also be there. So we actually have the height of the bottom part or the top part, and the base of the bottom. So it is the height of the base and the base of the base, or the height of the top and the base of the top. Okay, multiply by the height of the prism. So we are, notice something, we are using different notations here. This one is capital letter H, this one is small letter h. This is to denote, to say this is the height for the bottom or the top, and this capital letter H is actually the height of the prism. So we are actually having two heights here. And remember, we actually name our right prisms looking at the two-dimensional shape that was translated. So if it's a circle that was translated, then we have a cylinder. If you don't want to call it a cylinder, you can call it a right circular prism, because it is generated by moving a circle. Okay, and the second one is actually generated by moving a square up or down, okay, then this becomes a cube. You can't call it a squarecular, a right squarecular, no. The special name for a prism where we have actually translated a square either up or down at an angle of 90 degrees, then it becomes a cube. This is a special name for it, okay. And then we also have a rectangular prism. We call it a rectangular prism because of a rectangle that was translated, okay. The cube and the rectangle are also known as cuboids, okay. Now we also have our triangular prism here. So these are the basic right prisms that we'll be dealing with so we'll be calculating the volumes of these right prisms, okay. Now let me take everything and put it at the corner so that we actually have a space where we can actually work here. Now we'll actually take them one by one. Let's check the first one. We actually have this shape for the first one. We have this shape for the second one. We have this flat shape. These are flat shapes, all of them. I said we can actually talk about prisms after we have translated flat shapes. And this is also, so I'm using different colors so that you can actually understand. It's to enrich your understanding. So the blue one for the cylinder, the green one for the cube, and the red one for the rectangular prism, and the black one for this one, okay? Remember, this one is actually having the radius and the circumference, okay? You revolve the radius around, then it gives you the circumference. By the way, what is the name of this shape? A circle, yes. Okay, this is a circle. Now, and then this one, the side and the side, they are equal. And then what is the name of this shape? A square. Correct. And then we also have this one, which has the length. The length is the longest side, okay? The length, the breadth. If you don't want to call it the breadth, you can call it the width. And then with this one, we actually have the height and the base. The height will always be drawn from the apex or from the corner, okay? The corner of a triangle to the opposite side, okay? As long as it is a perpendicular drawn from the apex to any side of a triangle, then that becomes the height of that particular, okay? So we agree to say the first one is a circle, the second one is what? It's a square, and the third one is a rectangle. It's a rectangle, and automatically the last one will be a triangle, okay? Now, why am I putting them here? Because I'm saying the volume or the three-dimensional objects are actually a translation of two-dimensional, either up or down, to the left or to the right, at an angle of 90 degrees, okay? So it is important that we actually know the formulae to calculate the areas of all these flat shapes, because they will actually come handy when we will be deriving the formula for the volumes of these prisms, okay? Now let's revive our minds and check. By the way, what is the formula to calculate the area of a circle? Yes, area is equals to pi r squared, okay? And then for the square, yes, you are with me. Area is equals to side squared. And then what is the formula to calculate the area of a rectangle? This one is simple, okay? Yes, correct. That will be the length multiplied by the breadth. And automatically the area for the triangle is the one that you did in grade 8 and grade 9, okay? This is equals to half of what? Of the base multiplied by the height of that particular flat shape, okay? Okay, right, for convenience and for interest's sake, for enrichment, let's also talk about the perimeter, which we will also talk about them when I'll be dealing with the total surface area. But for now, let's just put them down, okay, to say it is important that if we know the areas of these flat shapes, we must also know the total distance around all these particular shapes. And the total distance around a shape is actually a perimeter. And the perimeter of a circle has a special name, which is the circumference, and is given by what? By 2 pi r, okay? And at the same time, the perimeter of a square will be all these four sides together. Then it will be 4 multiplied by the side. And then you look at the rectangle, you are actually having two lengths, and then you also have two breadths. You add them together, they give you the perimeter, okay? 2 lengths plus 2 breadths. And then now the last one will be a triangle. With a triangle, to be safe, because we don't know what type of a triangle is this one, It can be equilateral, it can be isosceles, it can be scalene, it doesn't matter. But the fact is, as long as it's a triangle, it has 3 sides. Okay? So we can actually say side number 1 plus side number 2 plus side number 3 to get the perimeter. Okay? Now, but what we will be looking at, the one that we'll be using, the one that will actually come handy is the formulae for the areas. Okay? Now let's check the general formula for all volumes, for volumes of all prisms. Okay? So the general formula is given by volume will always be equals to the area of the base. And remember, the base of a prism that is correctly orientated, that is correctly put, the prism which is a right prism. A right prism, it means the top part and the bottom part are identical. They are congruent in every way. Okay? So the area of the base or the area of the top multiplied by the height of the prism, that will always give you the volume. Okay? Now we will use this the general formula to come up with specific formulae for all these particular prisms. Okay? Let's check the first one. If we are having a cylinder will be equals to the area of the base, and our base is a circle. And the area of a circle is pi r squared. So it will be pi r squared multiplied by the height of the prism. Okay, every time we'll multiply by the height of the prism, because the reason why they are prisms is because of the third dimension, which is your height. Okay, now if we look at a cube, the formula to calculate the volume of a cube will be the area of the base. Our base is a square. A square is side squared, so it will be side squared multiplied by the height. The height is the same because all the sides are the same. So s squared multiplied by s is s cube. Okay, now let's check the rectangular prism. The formula will be length multiplied by breadth multiplied by height, because the area of the base is a rectangle, and the area of a rectangle is calculated by multiplying the length and the breadth. But always we multiply by what? By the height of the prism. And lastly, we'll actually have the volume of a triangular prism. Remember, with a triangular prism, you are having 2 heights. The height of the base or the top multiplied by the height of the prism. Then the height of the prism is represented by a capital letter H, or you can call this one H1, H2, it doesn't matter. But it becomes very simple when you say small letter h and capital letter H. So the area of the base, our base is a triangle, it will be half base multiplied by height multiplied by the height of the prism. Okay, how hard is that? Very simple. Okay, so without wasting any time, let's move on. Now, why are we saying this h is the height of the prism? Is because if you take this prism and rotate it in such a way that this part becomes the top part, remember the top part and the bottom part are the same. Okay, so it means this is the same as the area of the base. So when it is correctly placed is when the top and the bottom are parallel to one another and the top is on the flat surface. Okay, then this side becomes the height of the prism. So when it is put like this, it is not easy to tell that this is the height of the prism. But for you to tell the height of the prism, you must first rotate it and put it correctly in such a way that the bottom is on the flat surface, and the bottom and the top are actually parallel to one another. Okay. Now let's look at how we can actually calculate volumes of right prisms. Okay, then I'm taking you back to the original prisms. Okay, I want us to calculate looking at the practical setup. Okay, now let's take the prisms that we had, all of them. Okay, the Coca-Cola can, blah 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 blah. Automatically, this one is a cylinder, the second one is a cube, the third one is a triangular prism, and the fourth one is a rectangular prism. So suppose I give you the dimensions to say, okay, from here to here is actually 20 millimeters, and the height of this particular can is 30 millimeters, and then now you have a cube. Remember, a cube, it means all the sides. If you are given that this is a cube, it means all the sides are equal. So there is no need for me to be writing 6, 6, 6, 6, 6. As long as we have 1, 6, we know all of them are equal. And then you have a triangular prism. Remember, the triangular prism will have the height of the base when it is correctly put. Okay, when the orientation is correct, and the height of the prism. Okay, This is not the height of the prism. 1,4 meters is not the height of the prism. You must first put it in the correct order. Okay. Then you also have your rectangular prism or the shoebox, where your length, which is the longest side, is 5 centimeters, the breadth is 3 centimeters, and the height is 2 centimeters. Now, let's calculate the volumes. Let's calculate the space, the amount of space contained within each and every right prism that we are having here. Okay. Now this will be the solution for the first one. Okay. We'll actually say, okay, this is a cylinder. It means a can is cylindrical. Okay. Then the formula to calculate the volume of a cylinder is the area of the base, which is pi r squared multiplied by the height. But remember, r it's the distance from the center to any point on the circumference, and the one that is given is actually the diameter. There is a relationship between the diameter and the radius. Diameter is twice the radius. If you take radius plus the radius, or radius times 2, you get the diameter. And the diameter and the radius is actually half of the diameter. Okay? So it means our radius in this case must be half of 20. Now you actually have pi multiplied by 20 divided by 2 whole squared. And then multiply by the height of the prism. There is no need for you to be writing the units now. You can write the units at the end. Okay? Now from here you play your maths. Okay? You have pi multiplied by 10 squared, 100 multiplied by 30, which will be 3000. You multiply that by pi. Please do not use the simplified version of pi. Don't use 3.14 unless the question dictates. Okay? Just use pi raw as it is. If you use it raw as it is on your calculator, your answer becomes more accurate than when you have written 3,14. Okay? Or 22 divided by 7. Okay, now the final answer will actually be, the volume is given to be 9,424,78 millimeter cube. Let's look at it. It's millimeter cube because r squared, it's millimeter multiplied by millimeter is millimeter squared multiplied by the third height. Then so the volume is always measured in cubic units, and the area is always measured in square units. So in this case, because it's a volume, then it will be millimeter cube. Okay. So if this was an exam, this is how it will be marked. You'll get a mark for the formula, and then you get a mark for substituting into the correct formula. You get a mark for simplification. Actually not the simplification, but for the value of the radius, and then you also get a mark for the final solution. Okay. How hard is that? Very simple. Okay. Now let's check the volume of a cube. You do the same. Your solution will be, you write down the formula, and then I know you know the formula. Okay. Yes, the volume is equals to side cube. So because you have your side, you'll just substitute your side by 6 cube, then that will give you 216 cubic centimeters, because this is now centimeters. It's no longer millimeters. It is now cubic centimeters or centimeter cube. And this is how it will be marked. You get a mark for the formula, you get a mark for substituting into the correct formula, and then you get a mark for the final solution. Very simple. Okay, moving along, then we take the triangular prism. You do the same. Your solution will be, write down the formulae, but before you write down the formulae, your orientation, you must orientate it correctly. If you put it like this in such a way that the top and the bottom are the same, then now you can identify the height of the prism. Okay? Now you write the formula, V is equals to half base multiplied by height. So height of the base, which will be 1,4, and then height of the prism, which will be 4,5. All right, you substitute there, you play your maths. Okay, I can take it back. Then you play your maths there, then your final answer will be 30 cubic meters, because now it's meters, the unit is meter, or 30 meter cube. And the same thing will apply here. Likewise, you get a mark for the formula, you get a mark for substituting the correct formula, you get a mark for the final solution. Okay. Lastly, let's check the solution for the rectangular prism. You do the same every time. Write down the formula, which will be volume is equals to length multiplied by breadth multiplied by height. Remember, the length is the longest side. You can't say V is equals to length multiplied by breadth multiplied by, and then you substitute length by 2. That will be wrong. It means your substitution will be wrong. Length must be the longest. Okay. So you actually have what? 5 multiplied by 3 multiplied by 2. 5 multiplied by 3, 15. Multiplied by 2, you have what? 30. And your unit is what? Is centimeters. So you have cubic centimeters. And the same thing will apply. You get a mark for the formula. You get a mark for substituting into the correct formula. You get a mark for the final solution. So people, this is exactly how you will actually calculate the volume, the volumes of different prisms. The cylinder, the cube, the triangular prism, and the rectangular prism, using the correct formulae that we have actually derived. And remember that a prism is a translation of a two-dimensional shape, either up or down, or to the left or to the right at an angle of 90 degrees. Okay, this will mark the end of this particular session. So people, in the next video, I'll be specifically looking at the total surface areas of prisms. Okay. Now, don't forget to subscribe, like, and share. And remember to comment in the comment section. Your comments actually help me in actually they help me to develop my presentations in the future. Thank you very much. Thank you for watching. Don't forget to subscribe, hit the notification button, and like. And then goodbye for now. And God bless.